Hello everyone, my name is Mahmoud Hashemi, and welcome to PyGotham 2017, a plug for plugins. It's a talk about plugins, and it's here for you. Let's get started. All right, so first off, plugins, right? This is what you came for, is right in the title. We all know what they are to some degree. They may also be known as add-ons, components, modules, themes, widgets, extensions. Really, there are a lot of phrases, a lot of terms. But what are plugins really? And I wrote a definition, which I checked was actually a haiku by accident. So plugins are pieces of software loaded by a core program to add behaviors. Emphasis on behaviors. Yeah, it turns out you could just add commas and white space, and it turns into a tuple and a haiku. But yeah, pieces of software loaded by a core program to add behaviors. So here's the thing. I was doing a project recently, and it was starting to get kind of big. I was working on it with multiple people, and basically one of these guys said, more experienced engineer than myself, I think we need a plugin system. And I had an immediate, visceral, negative reaction to this that I felt I needed to explore later, right? I don't know why, and so I introspected a little bit. Why did I have this negative reaction to plugins? Well, the first thing that came to mind is that plugins are sort of functional, but not very dignified, right? They're like a plug. It sort of calls to mind an image like this, you know. You need it, but like you don't want to think about it, right? This is the sort of the brand issue I think that there might be with plugins. But then also I thought a little bit deeper. I'm like, maybe 90s advertising has ruined my mind, right? And all I hear is the jingle, plug it in, plug it in. Anyways, and so I was like, well, that sounds like a code smell, right? I don't know, I don't want my code smelling like potpourri. But no, I thought a little bit more. I'm like, wait, I ran a WordPress site once, and I suppressed this memory, but like, man, these plugins broke my code a lot. I was pasting PHP into the browser, right? That's not a good pattern. I don't want to be like that. But then I was like, wait a second. I remember I used to do Java, right? I had to use Eclipse. And for it to be worth anything, I had to install these plugins in this interface, right? And whenever you go find how-tos for this, there are just so many boxes, red boxes, blue boxes, arrows pointing every which way. And frankly, I think that Java UI designers should just take a hint and start building these red boxes in, right? Because every UI seems to need them. But I had some really bad experiences writing, software that required plugins. But then I was like, okay, I swallowed my pride. I re-repressed some experiences, and I'm like, wait, there are a lot of plugins that work, right? Maybe this isn't such a bad pattern, right? In fact, they work so well, I don't even notice them most of the time. My browser, right? Uses plugins galore. Even a lot of internal functionality is implemented as plugins, right? We all remember there were days when there was no inspect element. There were no developer tools. Firebug came along and changed the game, you know? Now it's built into your browser. Kernel modules, right? You definitely don't think about those on a daily basis, I hope. But like basically they're there and they work great. Your shell, it's not just the kernel. You know, you have a bash RC, you can change your prompt. That's a type of plugin in a way. And good editors, not Eclipse, right? But like from Sublime Text to Emacs, that also, you know, they also rely heavily on this architecture. So many, many, many more places use this architecture, and maybe it shouldn't be so maligned. So basically, what should we talk about today? We're going to talk about why plugins exist. We already know what they are. We already went over some examples. Let's talk about why they exist, what reasons you would have to use them yourself, and then how you might do that in a Python application. So let's get started. So why plugins exist? When I thought about it, right, plugins exist at a stage in my development where like I'm writing code on a daily basis and I seem mostly unblocked and I almost never use plugins. You know, why do these things even exist? Well, when I started programming, right, I was just like the very first thing you do when you demo Python. You type Python at the shell, and you type 1 plus or 2 plus 2, and then you know you get 4. You're sticking values together, right? And people are like, well, that's not like so cool. I mean, I have a calculator already. I wear it on my wrist. It's a cool watch. Anyways, but then, you know, it's like, well, but what's cool about this calculator is that you can have it across many lines. So now we're sticking lines together. And eventually, you can stick functions together and start composing those. And when your functions get too long, you can split them up into more functions and more files, modules, right? And beyond this, like this is most of the code that we do on a day-to-day basis. But what we really want to do is we want to stick behaviors together, right? This is why there's such a big craze about microservices and why there was such a big craze about shared libraries, right? We want to sort of spread out functionality in packages that aren't just functions and modules. We want to have these behaviors that go together. So we want to decouple our modules and functions, turn them into something higher level. So when to use the plugin architecture? Well, there are a few reasons to do so. One is you get a reduced core program size. So you can have a really heavily tested core part of your program and then add things onto that sort of ad hoc. And that core can be well instrumented with good logging. When a plugin fails, you can give a nice message on that. You know, it gives you a solid piece of core software. Another cool reason to use it, working around some IRL complexities. Let's say I have a cool audio player and I want to play my OGG files and my FLAC files. Well, that's no problem. That's perfectly fine free software. I can do that day after day. But go back a couple years, right? If I wanted to do MP3, well, now I need a letter from Mr. Fraunhofer. You know, I need to go to his website and get the MP3 codec. You know, so plugins give you a way to work around stuff like that. But at the end of the day, you need plugins anytime you're going to build an application that you deem open. If you're going to open something up to a community, right, you need to establish an API for adding more code to that project. You know, you can do pull requests for a little while, but it's not really open until you have an API for code integration. This is very true of applications, as we will see. So we're going to talk about some case studies now, how plugins actually get used in the Python world. And for this, I'm going to start out with a favorite application of mine known as conda. Anyone here use conda before? Oh yeah, I see some hands. So you may not know this, but conda actually uses a simple plugin system internally. And I think it makes for a great example. I think you'll agree too. So first of all, if you haven't used conda, it is the Python first cross-platform package manager. It's weird to think of it like that. Most of us just think of it as some sort of replacement for pip that doesn't require me to build NumPy. But I mean, now wheels exist and there are other reasons to use it too. For instance, you can, you know, like right here, I'm conda installing NumPy and it fetches package metadata, solves package specifications, and then installs libg-fortran. You know, didn't need to install that using my system package manager. And I get my NumPy and OpenBlast too, and I'm having a blast. So, yeah, basically, if pip and virtualenv had a more powerful fusion dance form, this would be conda. Now, inside of conda, which you can go visit on GitHub, /conda, and inside of conda, you will see that it has a CLI package. And inside that CLI package, you'll see a main.py, a main_info, a main_search, and you'll also see a main_install. So when I ran that install command, it was using code inside of that main_install that was loaded by that main.py. You know, so like these are the first hints that we have a plugin system going on. Let's look at how it actually works. I've sort of rewritten it to fit on a slide. Hopefully all of you can see this. First, let's look at the plugin. We're looking at main_install, the same thing that installed my NumPy. So if we look inside this module, we see two top-level functions. The first one is configure parser. This takes a subparsers object. For those of you who are familiar with argparse, then you know that subparsers is not actually a list, it is an object. And the thing we do with this object is we add a parser to it. We add the install parser, description, and help messages to that top-level parser object. We add an argument, a revision, and then, this is, I think, the most important line. I'm going to put a laser on it. The most important line, set defaults, func equals execute install. Execute install refers to this function down here. And what it's done here is basically that parser object now knows that func is execute install. This is going to come in handy on the next slide. For the actual execute install, you notice that it takes two parameters, the arguments and the parser, and then it does the actual install. So what does the core look like? The core conda CLI code has a main, and that main takes an argv. Whenever you're making a main, have it take an argv and pass the argv in. That's a good pattern. You get that one for free. All right, basically, within this main, we make an argument parser, and then we iterate over conda.cli main underscore suffix for suffix in main modules. That would be like install, info, etc. Right, just out of that directory. For each of those modules, we dynamically import it using import lib. And then we call the configure parser method on that imported module that we saw in the previous thing. So right here, that configure parser is getting called right there. So then we are safe to parse arguments, and we're safe to call the default function. And finally, we exit with the exit code. So what's interesting about all of this is that basically this configure parser, all of this dance, is so that when you call conda-h, you get a nice top-level help description of every single subcommand, every single plugin that's in the conda CLI. And we've done this by virtue of hooks that are in the plugins that actually are able to raise up their interface to that help string. Okay. That's the simple version. Let's talk about some pros and cons. So the first pro is that it's simple, right? This is basically as simple a plugin system as you can get. It gives us dynamic loading of hooks. I think that's basically the very core of what a plugin needs. And importantly, it only requires the standard library. This is a pattern that you can use now to extend your command line tools more sanely. The cons, though, it's not really systematized in a way that you can kind of use yourself other than copying it. You can't pip install something that will let you do this. You have to copy this pattern. And it's not user-facing. It's great that this is internal, right? And it makes the conda code cleaner. Imagine that you were trying to submit a pull request to enhance conda with a subcommand. You know exactly how to do that. Your pull request isn't going to be messy and like touch a bunch of code. It's just going to add one more file to that package. So, but it's not truly user-facing. You as a user will still need to go to GitHub to actually submit that pull request. All right. So let's look at a system that is reusable, that is pip installable, that is user-facing. So this is a popular reusable plugin system called pluginbase. And this is from the makers of Flask and Click. Any Flask users out there? Any Click fans? Click is a little bit newer. Got some Click fans. Okay. So how did the Poku guys do plugins? They give you 3 steps. These are a little bit weird. Bear with me. All right. So step number 1 is that you import pluginbase after pip installing it. Then you make what's basically a fake package that's going to live in your sys.dot modules, and that will be where your plugins are importable from. Already, if you've done some Python metaprogramming, you know this is getting into some weird territory. It's made a fake package in sys.dot modules. Step 2 is you make a plugin source and you tell it the paths where to find plugins. Notice that these are relative paths. I'm going to criticize that in a moment, but right now I still have a step 3 to get to. Step 3 is you say with plugin source using a context processor, right? And you say from your application.plugins import my plugin. Your application.plugins, again, that fake sys.dot modules package up here. And then you can call this hook do something cool, which wasn't defined in any sort of contract or anything like that. You sort of have to make that up for yourself. But what's interesting here is that we have this sys.dot modules top-level fake package. We have relative paths that we have to pass in, and we have this context processor. Okay, so what's happening here is that basically, let's talk about the pros first, actually. So it's generalized. You can pip install it. You can pip install it. It is user-facing. You can make those relative paths something in the home directory, right, that basically a user can drop a py file into and load a plugin from. They could copy and paste some Python plugin into that directory. Got that WordPress fun back. Now, let's talk about the cons. So, number 1, there's that copy and paste. There's no actual distribution story here. You still have to copy and paste. You still have to worry about your Python path being set appropriately. There's a lot of path wrangling. in their examples, there's all these relative paths everywhere, and I guarantee you, the thing that made that Eclipse story so bad was like the class path being set wrong, paths not being pointing to the right places, and basically foisting that back on you, the plugin system user, is a little bit inconvenient. Trust me on this one. And also, finally, it attempts to localize modules. This is pretty strange. That is to say that basically it allows you to simultaneously load multiple versions of a Python package, of a plugin. And so let's take a brief aside and talk about modules for a moment. Python's built-in plugin system. You might not think of them as this, but that's what modules are. Modules let you extend your Python execution environment, and they all have access to the full Python state, and you can do a lot of cool extendy sort of behaviors with the module system itself, the import system itself. They are simple, but also not so much. If you've ever done PEP 302 finders and loaders, then you know that the import system is quite complex. Earlier today, we had someone implement merge sort on top of the import system. We take it for granted when it works, and then when it doesn't work, we're back in that Eclipse zone. But the important thing I want to stress is that Python made a design decision, right? And that is that modules are global. And when you have a certain library, a certain package, you get just one version of that. And it's up to you and your fellow developers to work out what that version should be. You can't pip install multiple versions of, say, Django into the same virtual env and expect everything to be hunky-dory. In fact, pip will uninstall that for you before it installs the newer version. So what pluginbase does is kind of strange because it actually name mangles those plugins and tries to make it work automatically. And I feel like that's pretty un-Pythonic. So despite it being the most popular Python plugin system, it might be something you want to take a deep breath before diving into. So basically, that coworker of mine who said, let's use a plugin system, he said, there's a really cool pattern that is kind of underused in the Python community, and that is entry points. So the system he ended up building is called Gather, and you can all rush to GitHub and start it. He'd be very thankful. But basically, we have an entry points-based system. Who here has heard of entry points? So it's not nearly as many hands as we're using Flask and Click earlier. Basically, this is built into setup tools. And if you use pip, then you have setup tools, more or less. Setup tools is all but built into the Python ecosystem now. And setup tools defines entry points as a simple way for distributions to advertise Python functions for use by other packages. Kind of a mouthful, even though that's shortened. They should really try writing a haiku. But basically, the Python packages can now advertise certain functionality within themselves at install time. For instance, so basically once you've installed it, how do you get access to it? You import package resources, which is part of setup tools, and you can say for entry points in either entry points of a certain label that I specified earlier, I can call entry point.load and make a registry. This is the core of Gather, Don't go rewriting it, but this is the core of Gather. If you want to know more about entry points, you should check out this blog post by Amir Racham. It just came out this year, super fresh. All right, so I'm going to actually demonstrate what Gather looks like, and I'll show you sort of how entry points work in practice. Coreapp.py, first we need a core application. We have this coreapp.py, and we make a global plugins object. This plugins is a Gather collector. Then we have a main that takes an argv. In this case, we pass in the sysargv like so. And we're just going to collect all of our plugins that are co-installed with us, and then call one based on the name on the command line. That's not quite the right index. All right, but now we just need a plugin, right? We have the core, it fit on a slide. Let's get a plugin that fits on a slide. So we say from core app import plugins, and we do plugins.register, this useful hook. And by virtue of this decorator, we now have a plugin that can be accessed from that core application. It's a very useful plugin. It's very useful. I named it useful, and we celebrate usefulness with a yay printout. All right. It's Python 2.3 compatible. Anyways, so now we need that special sauce. Now we get to see entry points in action. So if you've ever written a Python package before, you know you need a setup.py. Here's your setup.py. I've called my my plugin package, core app plugin. I gave my name to the author. I did a calendar-based versioning system, and I have a single file, core app plugin.py. And then here's the special sauce right there. Entry points, gather, package equals core app, plugin. And you can ignore the package and plugin, that's sort of just fodder, but this core app thing advertises that this package contains a plugin for core app. Right? So this package, core app plugin, is a plugin for core app. Seems easy enough. And once we install everything into a single virtual env, pip install core app, pip install useful plugin, I can call that hook with core app useful hook, and it prints that yay. So this is actually a lot of work compared to that conda first example. You know, this is relatively not very simple. What are the pros of taking this approach? So first of all, it uses standard setup tools. We've stayed as close to the standard library as we possibly can to take advantage of this new feature. It's developer facing, so it's not totally internal. The way that you kind of distribute things is through pip. By pip installing everything into the same virtual env, you now have all those packages. You leave all the path wrangling to virtual env and to your Python path. All of that machinery works as easy as can be. And you get free hosting from pypi.io. And I didn't get to demonstrate this here due to real estate, but plugins are independently usable and testable. So you can have that plugin package also provide its own command line tool and use that as well. So you don't over-specialize your plugin logic and make it inaccessible to people who don't want that whole big core app. The cons of this are that it's only user-facing if your users are developers. So you still have to be able to pip install them. If you want to distribute it to people who aren't developers, then you need to figure out a different packaging story. I have a separate talk on that. I tell you all about PEX. If you haven't looked it up, PEX, Python executables, can totally solve this part for you. Now, you know, just due to time constraints and so forth, basically, I did not get to go through all of the Python plugin systems, but basically, I remember when this top one here, Stevedore, came out. It's now part of the OpenStack project. I remember when that came out, it was like 2009 or something like that. Maybe that was just when I first heard of it. But I remember like, oh man, I was already thinking, another one? Like, there are a lot of these systems. But interestingly, there are a lot of gaps to fill. There's still a lot of things that aren't covered by this. And so basically in this list, I have twisted.plugin, which has been around for a long time. I have Venusian, on which Gather is built. You know, if you are a Django user, it's totally valid to think of apps, middlewares, and the command line extensions as plugins. You know, Sphinx has an approach. You know, there's just, even the SQL Alchemy dialects, when you put MySQL in your database connectivity URL, that is loading dynamically something from a Python package that needs to be co-installed in that same virtual env. So even those are plugins. And basically, they're all around you. They're working really well, and you should consider using them in your libraries and applications too. So, sort of wrapping up here now, we learned that plugins are redistributable components for composing behaviors. It's getting that next higher level after functions, after modules, composing behaviors linked into your application. It is the architecture for scaling development. If you have a bunch of developers who are working on the same application, if you aren't using plugins, you're probably creating more developer friction than you need. If you're going to open source something, you should have plugins so that people aren't left constantly reapplying patches of customizations to your code, right? Actually care about your community, actually use a plugin system. We also learned that not all plugin implementations are the same, and none of them that I've seen so far are perfect for that matter either. I think the real key takeaway for you out there is that don't be afraid to actually roll your own. Look at that list, right, that I just showed earlier. Don't hesitate to say that my application has specific needs, right, that aren't addressed by these systems, no matter how many stars they may have on GitHub, and I'm going to build something that works for me. So, yeah, I guess that's basically it. Thank you. I have time for questions? Oh yeah, we got a question back here.
I think maybe a suggestion might be useful to distinguish. So we have lights here that aren't pluggable, but you know, the other lights you just stick in the wall. Modules to me are more like these lights. You've got a hand wire them in.
Absolutely.
It might be useful to distinguish that from something where you can just
So the comment here is that basically there are different levels of plugin systems, and absolutely you're right. I mean, basically if we really explore it, every time I boot up my system, I'm loading kernel modules, right? Every time I start an application, the dynamic linker kicks in, brings in SOs, right? Then my Python actually starts, and I'm importing libraries. These are all plugin systems at various levels, and then, right, I have a plugin system that I built just for my application that the user actually sees. And so this sort of composing is happening all around us, and it's an architecture that I think that we can benefit from embracing. By the way, it's a break right now. Feel free to ask more questions. I'll hang around. If you gotta go, then note that here is the blog post that has links to all of those plugin systems, and you can go exploring there. And I do a little bit more exposition and exploration as well. But if there are more questions, yes. Sure. So mixin. So the question is, how do mixins compare to plugins? You know, if you really bend your head, bend your mind, you can sort of think of mixins as a type of plugin that works for the inheritance system. In general, I think that popular opinion and my own as well, like, has sort of turned against mixins to some degree and favoring composition over, using the heavily overloaded inheritance system. Yes.
One difference between some of the plugin systems you talked about that you didn't highlight is the degree of explicit configuration needed to enable a plugin. So some of them, like
yes.
high-test plugins or anything entry points based, you just pip install something and it automatically turns itself on without any other changes.
Right.
Do you have thoughts on the pros and cons of that?
Absolutely. So if I had more time, where this presentation would go next is basically into contracts and dependency injection, right? So the plugin system that we actually built on top of Gather, right? We're constantly composing here. But the plugin system that we use internally at work to build on top of Gather does use a dependency injection system and does have flags for wiring on and wiring off the plugins. Now, basically in the Gather system, you pip install and pip uninstall to enable and disable those plugins, and that works at some level, but beyond that, you're going to need to basically define some of your own parameters. That's a very good point, though. Okay, sure. So, I mean, yeah, I'm just fielding more questions as long as the break is happening, but at some point, they're going to kick me off the stage. Yeah. Yeah, that's a really good question, and I probably could answer it when we made it, but since I didn't make it, I don't really keep that in cache. You can totally tell Moshe to enhance the docs. Basically, something was missing from Venusian. He liked the Pylons project's Venusian thing. It was a very lightweight plugin system, but I think that this maybe adds entry points to Venusian. I think that it might be something like that, taking advantage of that new, somewhat new. It's not even that new of a feature. It's just sort of not very often used. But yeah, so I guess I'll say, if you want to come ask Moshe for yourself, you can totally send me an email, mahmoud@shopkick, and you can, ask him as a coworker if you would like. Yes?
I think the guys selling t-shirts are leaving, so I should probably, if we want to buy a t-shirt.
Well, I've just been told that if you want to buy a t-shirt, the time is now. Thank you, Aaron. Well, yeah, and thanks everyone for coming to the talk.